I can't do this anymore, Shlok. I can't.
What's wrong?
I have an exam tomorrow for bio, and I know nothing about enzymes. I don't know what I'm gonna do.
You don't have to do anything.
What?
You're sitting right next to me. I have a perfect video here for you.
A video?
Please.
On what?
Well, I think it's a site called YouTube. It's where they show the videos. Oh.
Welcome to How to Ace Bio 141. The topic of today's video is enzymes. The following questions will be discussed in this video. What is an enzyme? How do enzymes catalyze reactions? How are enzymes regulated? What is feedback inhibition? What is an enzyme? An enzyme is a catalytic protein that speeds up chemical reactions. There's a cavity called the active site that has a shape that fits with a specific substrate or reactant. Enzyme and substrate are like a lock and a key. Only a specific substrate can fit into the enzyme's active site. How do enzymes catalyze reactions? There are 3 steps in this process: initiation, transition state facilitation, and termination. The first step is initiation. The enzyme precisely orients the substrates as they bind to the specific locations within the active site, forming an enzyme-substrate complex. The second step is transition state facilitation. Transition state is a high-energy intermediate state of the reactants during a chemical reaction that must be achieved for the reaction to proceed. The enzyme helps the substrates achieve their transition state by undergoing slight shape change. The change in the enzyme shape is a result of the interactions between the substrates and the R groups of the enzyme's active site. The activation energy of the reaction is now lowered and proceeds more quickly. The final step is termination. After binding ends, the products are released and the enzyme returns to its original conformation or shape. How are enzymes regulated? Most enzymes are regulated via non-covalent interactions or covalent modifications. Non-covalent interactions include competitive inhibition and allosteric regulation. In competitive inhibition, the molecule involved competes with a substrate for access to the enzyme's active site, preventing the binding of the substrate to the active site. In allosteric regulation, the regulatory molecule binds to a location other than the active site and changes the shape of the active site. This may deactivate the enzyme, which is when the change in the active site shape prevents the binding of the substrate, or activate the enzyme, which is when the change in the active site shape allows the binding of the substrates. In covalent modifications, the most common form is phosphorylation, or the addition of a phosphate group to the enzyme structure. This may activate or deactivate the function of the active site. Kinase is an enzyme that adds a phosphate group to the enzyme, and phosphatase is an enzyme that removes a phosphate group from an enzyme. What is feedback inhibition? In a metabolic pathway, a linked series of chemical reactions is catalyzed by enzymes, which help to break down or build up products. Feedback inhibition occurs when the final product inhibits the first enzyme of the pathway. Usually, the final product allosterically binds to the first enzyme and changes the shape of its active site. Doing so prevents the binding of the new substrates. Feedback inhibition helps the cell conserve its energy by preventing too much of the product from being made. Thank you for watching. I hope this video helps clear up any confusions you may have on enzymes. Good luck with everything, and I'll see you in the next video.